network automation. You have already heard some stuff about Ansible 2 weeks ago. Also last week there were Ansible mentioned a couple of times. So yeah, we will go quickly through the details of Ansible. In 45 minutes we don't have the time to go really deep in all the topics. For the exercise you will have to look a lot at the documentation. You have to read some stuff. If you have any questions, just drop me a message or ask in the exercise lessons. So the idea from this lecture, not from the whole module, but from this lecture, is that you know what Ansible is. You can describe it. You can also say the difference between Ansible and other tools we have. And of course we need to be able to analyze and understand some implementation using Ansibles. You have the exercise Ansible, and then you have the lab 1, who is marked where is Ansible 50% of it. So there of course you also have to develop a solution to automatically provision services for layer 3 and NPLS. I already uploaded the lab. It does not start this 3 weeks now, but you already have access. So you can already go through the requirements of the lab. There will be some parts, maybe, how can I say, a little shocking. You have to make, for example, a video of your solution. It's easier for me to mark if I don't have to run all the playbooks. So one part of the submission, who is new this year, is a video recording of demonstrating your solution. So before we go, we try something new. I sent you in Teams a link to this whiteboard. So the idea is that we now create here a small diagram about Ansible. Hope it works well. So I will paint something here. You can also open it, and especially the typing is quite hard for me, so if you can then just make the labels. So for example, if I it's a little difficult here, but maybe someone can then replace the things here, but let's add here some network devices. In the library you could find nicer symbols, so maybe someone has time to replace the symbols. So what we need is we have our network devices. Let's say it's a switch, it's a firewall, it's a load balancer, and of course we also have servers, and we want to automate this stuff with Ansible. So what we have here, we want to fill out, is this Ansible box. So somehow we have here already the idea that we can connect to these devices and execute commands. So normally if this would be a server, Ansible would generate a tar with all the Python code needed, ship it to the server itself, and execute it there. This does not really work for our network devices. So for our network devices, we normally have connection plugins. So we can add here connection plugin as a box. So maybe someone can add the text connection plugin here and connect to devices. So traditionally, if we look just some examples, we will see, for example, in our lab, the Cisco iOS collection where we need the network CLI connection plugin. So what's happening is Ansible still will create a tar archive with all the code, but it will execute it locally. So it will, on the machine or our control node itself, will execute the Python code, and this Python code then makes the SSH connection to the device and execute commands. So if we have the classical network CLI network connection plugin, this will be raw CLI commands. Then we can use Ansible utils functions for parsing this output and work with it. If you have already started with the lab, you have seen this. So this is one of the big difference between the Linux devices or Windows devices where we can execute Python code directly on it. Many network devices, they support Python, but it's not really the idea to, for example, on the Cisco Catalyst, spin up a virtual machine and execute their Python code, that this Python code then can make a connection to the CLI. So there are other connection plugins. I would just, we can make it later nicer. Let's call this connection plugin. Well, little thick, sorry. Yeah, we can have netconf with XML, for example, but of course we also can have APIs. So on a firewall, for example, we would have a firewall, we would maybe use the API. If we have legacy old Cisco devices, we need then to have CLI, raw commands, and if we have a modern iOS version, we can have netconf or something like this. So that's one of the main differences, of course. So what we also need, let me see, we can move. We need the inventory, right? We have already seen we have inventories. So what we have seen, for example, is a simple ini or YAML file where we define our inventory, which devices are here, so that we can connect to our devices down here. We need somehow our inventory plugin. And if we use the inventory, we also need somewhere to define what kind of task we want to run, and this would be normally done in a playbook. We also have heard about this ad hoc commands, and we will here again. Okay, now I broke my setup. Come on. Okay. Let's say this is a playbook. So a playbook normally contains one or multiple plays. So what we can have is multiple plays. And each play can, of course, have multiple tasks. Multiple tasks. To save some space, we'll just make it. Whoa. Yeah, we can do this later nicer, but inside of a play we have a list of tasks, right? So a play we kind of defined on which devices it is run. We have a lot of features we can use in this domain-specific language to define if this task has to be run once, for example, or if you can make loops. All this stuff you will see in the lab, and yeah, it is somehow powerful. On the other side, if you remember, we have also this Jinja syntax. So in this box down here, we definitely have also the whole Jinja engine, who is kind of everywhere. If we run a playbook, it is executed the Jinja so that we can work with the variables stored in the inventory. So what we have so far is the inventory, the playbooks, they together defined that we want to run the stuff on the devices down here. And yeah, of course, we also have then core modules, so modules that Ansible comes with it by itself. We have core modules, but what we also have is, since 2.9, the separation that all the stuff from the community is kind of in the Galaxy, Ansible Galaxy. So many features or playbooks or collections roles are installed separately now. That's one of the main reasons, is that Red Hat can support only the core and does not have to support the whole community code. So that makes it much easier. They can also validate and test some of the core features. So what we normally install are collections. I will paint it here. And the collection normally includes, or can include, roles, can include playbooks, definitely has a galaxy.yaml with all the meta information, also has a meta folder, and plugins. And plugins, if we go to the documentation, we see there a list of probably 10 different plugins, like inventory plugins. We can have modules where we then define our own modules we can call in our playbook with Python code. There are actions, there are caching plugins, there are these connection plugins who also can come from there. So yeah, Ansible is kind of extendable. It's Python code. Sometimes if I see some Python code, I am surprised how many ifs you can bring in 10 lines. But it is Python code, is used a lot, so there we can have an expectation that it's kind of stable. But of course, we still need to keep in mind that if we use a CLI interface for our network devices, it is still CLI. So all the issues with a interface who was not designed for a programmatic approach, we have to deal with it. We have to verify always in Ansible, but also in all the other tools, verify that it really is doing what you expect. It can happen a lot that Ansible or other tools have behaviors you would not expect. So don't assume it will do what you think. You have to verify it. In the demo will also show some examples that can happen, and I will just share some blog posts from people who have some interesting moments of realization. So yeah, what we have seen is the inventory. Typically in the beginning we would start with a simple ini file or with a YAML file, and normally we then also would extend this with group vars and host vars directories, where we can then add more information. So this is one approach. We can have this inventory, for example, in Git versionized, and use it as our source for the automation. If you have hundreds or thousands of devices, not sure if it scales so well then for you, so keep in mind. But of course we also have dynamic inventories, or then inventory plugins. So inventory plugins can be AWS, Netbox, CloudScale, infrastructure as a service provider in Switzerland, who is the founder was also here a student the same time I was a student here. They also have a plugin for the inventory, for example. So you can write their own, and yeah, you can use them. So it does not have to be in the YAML or in the ini file. There is also about the variables a good documentation. I think it's around 12 steps where you can define variables and which one has the highest priority. I will also send you some links to read, and also there are some nice moments people had, that for example the extended vars have priority, and if you change them inside the play, it will still have priority. So yeah, verify everything you're doing. Don't assume that it does what you think it does. A YAML inventory could look like this, really simple one. Here we can also add variables directly in this file. I normally would recommend to keep the file as simple as possible, and then maybe use host and group directories with multiple files. There is also one important documentation link who would be best practice Ansible, and there is also an explanation of what kind of data structure, folder structure you should have in your project. It does not mean that it is the perfect solution for you, but if you are not sure how to start, it's probably a good starting point to see the best practices. Yeah. So as I said, we have, for example, group bars, and we will then magically all the devices, we go back here, who are in the group root. Does not work, but I have. So for example, in this case, R1, R2, 3 and 4, they all will get the variables from the group router. If we have this file router.yaml, it will take it from here. If we need more flexibility, we could also make a directory router and put multiple files there. That's especially handy if you generate some variables with other scripts. So it does not have to be one file, it can be a folder, and there you can have multiple files that you have data structure. Yeah. So ad hoc commands is if we just wanted to execute one module. So for example, if we want to execute, let's say, our last working day, we want to execute a reload in 200 seconds on all our devices, we could use this command. Maybe not the best idea. If you want to see where is this MAC address, you can also fire a command at the whole inventory at the same time. Here at the pattern, you would say what kind of host. So you can type all, and it's the group all, the default group. You can type a group, you can type a host name like R1. So yeah, I don't really use this ad hoc commands much. Normally I use them in demos to show how Ansible works, but in production I don't really use these commands, because normally I don't use one command. I need at least two commands to verify or to do something with this output. Yeah, connections in our lab will be important, so we can define the connection plugin used. For example, here we would normally use the network CLI if we are looking at the Ansible in the traditional legacy CLI approach. So yeah, we can define this variable. For example, in this case it would make sense to define this on the group router, and then all the routers will have this variable. 2020, I believe, there was a change that we now should use this libSSH implementation by Ansible, and Ansible normally uses Paramiko, but now there were some issues with FIPS and also with performance, so there was a development with PyLibSSH, which is much faster. Here there are 2 blog posts, and yeah, also explains more in detail why this was developed and how we can benefit. It still has a fallback to Paramiko. If this is not installed, you probably will get a warning, but I recommend just add it to your normal dependencies, and then it is installed, so you can use the new library. Yeah, this is a really simple example of a playbook. We have in the beginning, in the header, here we have the definitions. So we say hosts, all routers we have. This is hosts, but it can be a group, it can be even a list of hosts. It does not have to be a string. We just defined here the pattern on which devices we want to execute it. Ansible normally would get effects. So on a Linux device, for example, it will look how many interfaces are there, how many CPUs are, what kind of Linux is it, and the same it would do for the network device. If we don't need this information, we can disable it just to be much faster. And yeah, we have then here 2 tasks. We will send the iOS config command host name with the inventory hostname. There are some variable names you have to know, like inventory hostname is the name we specified, but then we also have the Ansible underscore host who is used for the connection. So this probably you have to look up in the documentation. Yes. The question was how the get effect works with network devices, if I understand correctly. That's a good question. In the older versions, it collected the effects from the local machine because it was executed there. Nowadays, with the network CLI plus, we have to specify the platform. It knows which modules has to take for gathering effects. So the collection iOS, for example, has effect collection task, who is then called if it's installed. But yeah, you have to see which version you are using. The older versions, you could have wrong effects, definitely. And as I said, always verify if it really is behaving like this. Yeah. The second one is another DNS configuration command. So this, of course, we could also combine in one task. What is the big issue on this? If you remember the stuff we were talking in the last two lectures, what Ansible playbooks should be and how we should write them. These buzzwords we used, or these keywords. Idempotent. Is this one? It's not. Because it's kind of, well, maybe it is, but not really how I would do it. Because if we run it 10 times, we will 10 times get the same result. Hostname will be configured, and the name servers are configured. But the point is, it will do it every time. Normally, if we would implement something, we want to check if this change really is needed. Most of the time, we have some functions already, like if we want to configure interfaces, or if we want to configure VRFs, BGP, there are special modules. They most of the time are idempotent. So if we can, we should try to use them. Many times they are not exactly working how expected, then we have to make a fallback on the configuration module maybe. But then we have to be aware that this can lead to some issues if we, for example, defined a VRF multiple times on the interfaces. Yeah. Because what is the issue? If we here define the VRF on an interface, a Cisco device, for example, will remove the existing IP address. And if we then not configure this IP address anymore, it will be gone. Just this behavior of the network device is in the configuration module not really covered. So here we have to exactly know how the device behaves if we send something. So verify, test. Then in Ansible we can make molecule tests, so not exactly as nice as Python with PyTest, but we can make some tests to test our playbooks we are writing, or our roles. Collections. So as I said, if you work, for example, in our lab, we will work with Cisco iOS, there is a good idea to probably install the Cisco iOS collection. It's the same as iOS and iOS XE. iOS XE was before called iOS, so there is only one collection for this. Ansible itself can be powerful. I know one company, this one here, they used Ansible quite advanced. So they have, for the whole maintenance operations of the container platforms, they were managing for many companies, or still are, but now they have a new version, so they are not using Ansible anymore. They are using operators with Kubernetes, but they developed in-house more than 9,000 lines of YAML. So we could call them YAML engineers. There are some Python lines, not so many. some ginger lines, and this is beside of the collections and roles that are already existing. So this is self-developed. I don't want to imagine how many hours it was spent here, but if you are running updates on all the clusters weekly or monthly, it is definitely worth it to optimize and to automate. So Ansible scales can be used quite in big scale, but sometimes for the power, for the performance and all the stuff, you probably have to trigger some knobs that is performing faster. So, yeah. Any questions so far to Ansible? Pretty simple, right? So on the lab topology builder, I deployed a simple lab. We have here an Ubuntu server. We have 2 routers and 2 servers. They all have out-of-band management. So on the routers we have VRFs, just that we are not messing up the routing table. Here we don't have anything. We have DHCP IP on the first interface, but nothing else. What I did, in the end you have to see what is the best way for you to work. I, for the demo, choose to use VS Code with reconnecting, nice. Yeah, with the remote connection normally, if it works. So in the lab topology builder you would need to see the IP address. I hope I remember it. Somehow. If you store the SSH key, you don't have to enter all the time the password, if it works. That's now demo effect. Oh, come on. For the lab itself, if you have a stable Linux in a VSL or in a VM or natively, I would probably recommend you to do it on your computer with Git for versioning, and yeah, just to have all the tools. And okay, not what I expected, but we still will make it somehow. Oh, here. Sometimes in Visual Studio Code I have issues with seeing the prompt for the password. Oh, now, lucky. So, I created already here a short requirement. Maybe I should make it bigger. So, appearance. Now it's bigger and I don't find it anymore. Ah. Better? Can you read it? Or one more? It's okay, it's like this. Okay, so I already created the requirements txt because I recommend that you install Ansible and all the dependencies in a virtual environment. So on native Ubuntu, where is nothing installed, I had to install the venv extension for all of the package, and then I created the virtual environment, I activated, and I installed the requirements. And then I also can install the collection. So source, and now I have Ansible here. Hopefully, yeah. Just for reference, the version So yeah, now what I also did, I created an inventory, and I had this, I named it now demo lab. Normally you will have data structure with production, with testing environment, and maybe integration environments, and then you can arrange the data accordingly, or you have a connection plugin to, I think that's also true for any system you're using. I here had different ways to do it. So I would not combine all the different ways. I just want to show that you can, for example, define variables directly in this YAML. This YAML could also be an ini file. I've seen many people making the ini file just for the host definitions and then everything else doing in the host vars and group vars with YAML. So here we have a host 1. If we go here, we have one file, host 1, and we defined the Ansible host for the SSH connection. Host 2, we could also do a folder similar to the group was, all the same. And here we could have multiple files just for some organization benefits with the other IP address. And in the group, for example, we have the group Linux, and we define the user. We have different users for the routers and passwords than for the Linux VMs, so we have to define them. Otherwise, we could also, when we run the command, say, I want to use the user X, but because we have different users, we have to specify them. What we don't want to see is in any Git repository a password. So please don't submit any password, even if the password is ENS@lab and probably whole Switzerland knows this password. We should encrypt it. In Ansible, we can use Ansible Vault. You can do it here, for example, with Ansible Vault. Edit. I can edit this file in inventory group Linux, and then password, I named it. Now I have to enter the top secret password I defined, and I can see the file. So here, this file would be okay to submit to a Git repository because it is still encrypted. Of course, if you're in a production environment, you probably want to have a Vault system where you can interact with API, for example, HashiCorp Vault or any other Vault application. Yeah. So, then I made some really simple playbooks we can run. So this one would just gathering facts. Now it's set to true. And for all the hosts, and then we print it out and we can see what happens. What do you expect? We have to give here the inventory, of course, and now the playbook facts. And I had to specify ask vault pass. I could also put this in a file or something. Please then put it in the git ignore, that it's not accidentally executed. And now we have some red. We normally don't want to have red. So 2 tasks worked, but how well did they work, we have to see. Host 1, host 2 did not work because we wanted to have SSH connection with a password. For this, we would need an additional package called SSH pass. What would be the nicer approach, of course, would be using certificates, that we don't need password for authentication to the host. But for lab, we many times need or use SSH pass, so we can, of course, then install this. The router itself, we see the host name, the image they're using, what kind of type it is. So we have here some information from the router. So the reason why this worked is because I tested it already. So there must be here in the wrong keyboard layout, sorry. In the SSH there are already the well-known keys. Yeah, I remove well-known keys now and I can run it again, so it should also fail there. Because we are not knowing the fingerprint of the SSH, it now fails. So that is typically if you start something and you had never an SSH connection, it will fail. Sometimes it could happen that you are trying some stuff and on one device it works in the lab, on the other one not. Maybe it was because one, you tried if SSH works and you typed by hand SSH, you made a connection, and then the key is already stored, the other one is not working. We can, in the settings, of course, disable the checking. Not completely recommended that we ignore fingerprint checking. So what I did was here, created a new SSH pass playbook to firstly install SS pass, the way how you should do it with the built-in package, so that it is idempotent, and then another play where we execute a shell command. This one is now again not idempotent because it will be executed all the time. What we also want to have is, we have now 2 Linux hosts, but maybe we have 200. And we don't want to install 200 times the same package. It is idempotent, but on the other side, by default, Ansible uses a fork number of 5, so there will be 5 tasks parallel. And I need this local, so the reason I have here the delegate local is, I want to do it for the host, with this host information, but I don't want to do it on the host, I want to do it on my machine. And what I also added here is the run once, so we run this for all the hosts in the Linux group. If we have 200, it will run for 200, but only once. So as soon as it's executed once, it will stop. We also put a strategy plugin here with linear, so that we are sure that one is executed after the other one. So this should work. And the other one, for each device now, we want to have the fingerprint, so we will execute this for all 4 at the same time. Or at the same time would be a bad idea, because at the same time editing one file on the same host could definitely lead to some issues. So what we also can do is, we can in a play define the serial number. So how many forks can we have at the same time? This is also handy if you're updating a cluster. If you have a database cluster with 3 because of the quorum, and you update 3 of them at the same time, maybe not the best idea. So please first update 1, check if everything works well, and then the next one. So also there you can use this serial with the fork. If we start Ansible, we can also, with the option -F, define how many forks. We can define 500. Not sure if your system, depending, is really faster with 500 and 100, depending on your machine, of the resources you have, but we can define these numbers. So let's try if we still have time. This was SSH pass. If you have any questions, just shout them out. So now the first play is running, and this task should only run once. If we go up, we have to play SSH login with password. It was run for H1, not for H2, because here already the next play starts. And this one then is running for H1, H2, H3, R1, and R2. All is green. Really nice, right? We can run it again. And the first one is green because it was already there, did not have to change anything. The other ones are changed, and because of how badly I implemented it with this pipe, this is now probably 2 times in this file, if I'm correct. Yeah, it still works, but it's not nice. So if you build something, especially if you're using shell command, be careful. Another nice command I can show is Ansible lint. Ansible lint is a tool who evaluates your playbooks. For example, if you would go up and gathering facts, no, this is valid YAML because this is false, right? Ansible uses YAML 1.1, but it's not how you should do it. So Ansible lint would tell you, please don't use no. How would it be if you maybe kindly would use false? It sets in red and big. So you don't have to submit the code with Ansible lint with absolutely no errors, but it's interesting to use it, and all the rules are on the documentation page, nicely described why is this rule implemented and what would be the best practice. So that's also interesting to go through all the rules. Many you will probably not use, but could help you to improve your Ansible skills. Oh. So now the playbook before effects should run again, because we fixed all the issues, hopefully. Works for the Linux ones and also for the routers, so we should now see much more information. So we can see this is Linux virtualized by KVM. Yeah, a lot of information for Linux devices, for example. And in your changer templates, you could then access this information and say, if this is a VM, I want to do another job. If this is bare metal, I want to do something. So, time is running. I have now some really simple examples with Cisco devices here. So now we say on all the routers, in our case we have 2 routers, we don't want to get effects because we know all the variables already. We want to create the loopback. We want to print the output of this configuration task, especially for us to see if it was doing what we expected. And we will show the running config, what is in the running config now, and we will print and we will delete the loopback just that we can play with this a little. So, if you look at this configuration here, please think, what would you expect to happen? What should happen? Who believes this will be totally fine, everything will be green, and everyone is happy? Who believes this will be big and red? Big and red, big and red. Who thinks it will be green, but it will be not configured what we expect? So everything is green, that's good. We have 5 tasks, 2 they were changed. So also this, let's start at the beginning here. On router 1 and router 2, we sent the commands interface loopback. We said no shutdown. We said IP address, and we said forwarding VRF demo 666. We get the update, we get a warning here, so it is not idempotent, so that's nice if we are checking the errors. And here then the config interface, so that's what we see on the command. Wait, no, that's the R2. So now we have the print config show what is the configuration. In the configuration there is interface loopback 666 and an IP address. Where is my VRF? The VRF did not exist at this time on this device. It is not configured, so it's definitely not what we want to have. So now this IP address is in the default routing context. Probably not what we want. And there was absolutely no error. Everything is totally fine for Ansible. So be careful. I would have now a playbook to configure the VRF as well and then run it again. And the idea would be to say after the VRF is configured, it will be different again, because we would configure the IP address and afterwards the VRF, and this would delete the IP address again. So the result would be an interface in a VRF without an IP address. So if you're using CLI and iOS config, please be aware what you're doing. Be aware how the device may act and verify. Any questions? Okay, thank you very much.